Hello everyone, my name is Divakar Sehgal and I have just completed Google's intensive 5-day GenAI course, and this is my Capstone project built using the powerful Gemini API. Let's dive straight into the problem statement. My project, AI powered agricultural optimization, addresses a critical challenge faced by farmers. Selecting the most suitable crop from myriad options, this decision is complex, influenced by various factors like specific soil condition, individual farmer preferences, and dynamic market trends. My goal was to build a tool that can simplify this complexity. My solution leverages the power of generative AI. I have developed a system centered around a large language model equipped with specialized database interaction tools. This enables the AI to process relevant agricultural and market data, analyze the intricate relationship between different factors, and provide tailored data driven recommendations to farmers, ultimately aiming to optimize their agricultural outcome. Now let's walk through the code. The first step in setting up the environment and importing necessary libraries. Before running, ensure your Gemini API is configured in your system. I begin by installing the required Google GenAI package and uninstalling any potential conflicting packages like Jupyter Lab. Following that, I import essential libraries such as Pandas for data manipulation, SQLite for database interaction, and OS for file system operations. I then integrate the Google API key securely using Kaggle secrets and configure a retry policy. This is crucial to manage potential API quota limits, ensuring the consecutive calls for complex queries are automatically retried if the initial then data preparation and database initialization. I sourced my dataset from an Accenture hackathon which provided comprehensive farmer and market data. My process involves creating an SQLite database named agricultureoptimization.db. I load the farmer data into the table called farmer profile and market data into market data. The farmer profile table includes the feature vital for assessing field suitability such as farmer ID, soil pH, soil moisture, temperature, rainfall, and current crop type. And then I have fertilizer usage, pesticide usage, crop yield, and sustainability score. The market data table contains features relevant to potential profitability, including market ID, product, market price, economic indicator, weather impact score, seasonal factor, and consumer trend index. A core component of my system is the set of database interaction tools. I have defined three key functions that the AI can call: list tables, retrieve the names of all the tables within the database, describe tables, fetch the schema for a specified table, execute query, execute a read only select statement to extract specific information based on the AI's needs. These tools are integrated with Gemini API. I configure my AI model with detailed system instruction. This instruction guides the AI behavior, defining its role as an agricultural advisor and outlining a multi-step process. Inspect tables, ask clarifying questions based on available data, formulate SQL queries using the tool, and synthesize the result to provide optimal crop recommendations based on both farmer conditions and market viability. I then establish a chat interface binding my defined database tools to Gemini model. The notebook demonstrates a simulated conversation flow. It begins with an initial prompt prompting the AI to analyze the data tables. The conversation proceeds with the user providing specific details about their farm conditions such as soil pH, moisture, and temperature. The AI intelligently recognizes missing information like rainfall and prompts the user for it. Following the farmer's input, the AI can then consult the farmer profiles database to identify crops suitable for those conditions. Subsequently, it can query the market data table to assess potential profitability of those suitable crops based on the market trends. The AI synthesizes information from both databases to provide a final informed recommendation as shown in the simulation. This process leads to recommendations like wheat, rice, corn, and soybean. The user can then end the conversation by typing quit. In this project, I have primarily demonstrated three key AI capabilities: function calling, enabling the AI to interact with external systems, specifically my database, through predefined functions; long context window, allowing the AI to remember, utilize information across multiple turns of conversation from tools output; agents, configuring the AI to act as an intelligent agent using its understanding and tools to achieve a specific goal, providing optimized crop recommendations. finally, here are the references for this project, including the dataset source for the Accenture hackathon, the Kaggle Capstone competition details, and foundational material from the Google Gen AI intensive course. Now let's look at the code. As you can see, I have created a notebook in Kaggle. I have imported the input. In the input you can see the data that I used, farmer advisor dataset. It includes all the columns that I have specified, and market researcher dataset. Then you can look at the notebook and see the problem statement, code implementation, and then the initial libraries are imported, and then the Google API is integrated, and retry function is integrated. Then data preparation and database initialization, I imported the dataset, and then I initialized the tools, and then I integrated the tools into the Google Gemini API with the system instructions. I prompted the tool using the predefined user query, and then I got the conversation like this, which I specified into the PPT. I'm going to run this notebook to show you exactly how it works. Editor is loading, so now I started the session. Now it will run. So as you can see, it is importing all the libraries, and then it is able to run. The database is connected and imported into the SQLite, and then I have queried the database to find out what the structure schema of the table was. Instructions are carried out, and the entire conversation is conducted, and the end. Thank you for watching.